in this problem, we're going to deal with a certain kind of limit, okay? So in our case here, we assume that our sequence is convergent. It has this first term, a1, is equal to 1, and we define the next term in function of this the present term. So we have an plus 1 is 1 over 1 plus an. So we want to find the value of the limit, the L. So an is convergent to some L. So what's its value? So the key idea here in this problem is that here, so our sequence is convergent to some L. Okay, since an is the same with different term, it's just convergent to some L, the same L. So it has the same limit. So the limit of an plus 1 is L. Okay, so in general, if we have a sequence an that's convergent to some L, then an plus 1 is also convergent to the same L. Okay, so we assume that it's convergent. Okay, now our aim is to prove that to find the limit, to find the L, the exact value of L. Okay, but before doing so, okay, we wanna prove that this limit doesn't have a different value, it's not changing. Okay, so we have a1 is equal to 1 is bigger than 0. Okay, so we can prove that an plus 1 is bigger than 0 if we assume that an is bigger than 0. Okay, but we can do this by using induction. So we're gonna prove that an is bigger than 0. Okay, so we have the first term, a1 is bigger than 0. So we assume that this one is an is bigger than 0. Okay, and we're gonna prove that an plus 1 is bigger than 0. Okay, but we have this one defined in terms of an. Okay, so let's see, an is bigger than 0. So let's add 1 to both sides. We have an plus 1 is bigger than 1. Okay, so when we invert this one, so this means it's positive. Okay, when we invert it, we have an plus 1. It's less than 1, but it's still positive. It's not 0 since it's bigger than 1. Therefore, an plus 1 is bigger than 0. This shows that this one is bigger than 0. Okay, so we have proved using induction very quickly that an plus 1 is positive. Now, since we have this relationship, an plus 1 is 1 over 1 plus an, this one goes to L, and this one goes to L, so we can just solve for 1 over 1 plus L, where L is the limit of the an as n goes to infinity. So here, using multiplication, cross multiplication, we have L squared plus L equals 1. So we add minus 1 is 0. Okay, so now using the discriminant, so we have delta is 1 minus 4 minus 1, which is 5. Therefore, we have L1 is minus 1 plus square root of 5 over 2. And L2 is minus 1 minus square root of 5 over 2. This one is negative. It cannot be accepted. And moreover, the limit is unique. So this one is the only limit. So therefore, our limit is square root of 5 minus 1 over 2, which is 0.6. Okay? The value that we are looking for is this value here. But before we get to this one, we have to prove that the sequence, since it's positive, to get to this limit here. Okay, this proves that the limit that we're looking for is square root of 5 minus 1 over 2. And this ends our video. Thank you.